All right, Gen Chem, we are going to practice more concentrations today. We're going to do some more things with molarity, which is moles over kilogram, and molality, which is molarity, moles over liters, molality, moles over kilogram. So let's write that on the top of your notes. Now, this note page is not in your book, so I will add this note page to the Canvas page so that you can have it and print it out. Okay, so here we go. Molarity. It is signified with a big capital M. It is number of moles per liter of solution. And then the other one is molality. And that's signified with a little lowercase m. And that is number of moles of solute. And this is also solute per kilogram of solvent. Okay, so I think it's really important to make sure that you're looking at your units for each thing so that you know what you're driving at. So when we start, I'm going to try and put the units up front so that we can make sure that we remember what we're looking at. Okay, and also on this one, I'm not going to give you the number of moles. So we're going to have to convert from grams to moles here. So we're going to have to add a couple, like an extra step or two. So molar mass and converting from grams to moles. So let's dive into number one. So I've got 10.7 grams of ammonium chloride and I'm dissolving it in enough water to make 800 mils of solution. What will be the molarity? So I'm asking for moles over liters. Now the thing is, we've got 8 mils of solution, so we're going to have to convert that to liters, and we've got grams of ammonium chloride, so we're going to have to convert that to moles. Okay, so let's start off where we want these things. So if I want the grams to convert it into moles, I'm going to start off with my grams on top. 10.7 grams of ammonium chloride. And I want my liters, and my 800 milliliters is a volume. So I'm going to start with that one on the bottom. Now the next thing I've got to do, I've got to convert these grams of ammonium chloride into a mole of ammonium chloride. So I've got to find my molar mass. So I've got nitrogen, hydrogen, and chlorine. So let's look at our periodic table. So remember, we're going to go to the 10th on this. So nitrogen will be 14.0. Hydrogen will be 1.0. And chlorine will be 35.5. So let's add those up together. So here we go. I'm going to put them over here. So nitrogen, I have 14.0, and I only have one of them. Hydrogen is 1.0, but I've got 4 of them, so I need to multiply that by 4. And chlorine is 35.5. Okay, so when we add that up, let's see, that gives us 53.5, I would say. So we have 53.5 grams of ammonium chloride in 1 mole. So notice my grams cancel out, and I've got moles, which is what I want on top. Now I need to work on getting liters and milliliters. Okay, so milli means 1/1000th. So that means there's 1,000 milliliters. 1,000 milliliters, and I'm going to put that on top because I want milliliters that are on that bottom to cancel out in 1 liter. Okay, so mathematically, we're going to take 10.7, we're going to divide by 800, And we are going to divide by 53.5, and then we are going to multiply by 1,000. Now I've got 3 digits right here. So when my calculator comes to it, it says it's 0.25. But because I've got 3 digits here, I'm going to put a 0 there. Now, Canvas won't let you put that 0 there. So if you have something with a 0 at the end, don't worry about it. Canvas doesn't let you put it unless it's part of the whole number sequence. But if it's past the decimal, Canvas won't let you do that. So there are 2 ways that we can label this. We have moles of ammonium chloride per liter, or I could label this as 0.250 big capital M ammonium chloride. Both of those would work. Okay. Number 2, I've got 10.7 grams of ammonium chloride and I'm dissolving it in 800 grams of water. What is the molality? So here I'm not wanting moles per liter, I'm wanting moles per kilogram. So moles per kilogram. Our solute and our solvent is the same. So we're going to have to get this into moles, and we're going to need to get this into kilograms. Okay, so I'm going to start just with this. 10.7 grams of ammonium chloride, and I have my 800 grams of water. Okay, so my ammonium chloride, I need to get into moles, and we already did the molar mass up here because it's the same compound. So I have 53.5 grams of ammonium chloride in 1 mole of ammonium chloride. So my grams cancel out. I'm left with moles, which is what I want. I don't want grams. I want kilograms. So kilo is 1,000 grams, right? So I have 1,000 grams of water in 1 kilogram of water. So I have pretty much the same things here. So 10.7 divided by 800 divided by 53.5 times 1,000 divided by 1, that still gives me 0.250 moles of ammonium chloride per kilogram of water. Now, this would actually take up more space because I'm not doing just by liter. I now am separating out the water separately. So this would actually have more volume than the problem in number 1. Or I could write it as 0.25 molal, little m is molal, ammonium chloride. So both of those would be the correct way to write that. Okay, number 3, calculate the molarity. So molarity, we are still going for moles per liter. Okay, we've got 6.8 grams of silver nitrate, so we've got to get that into moles. And we're making 2.5 liters of solution. So let's start with our grams. So 6.8 grams of silver nitrate over 2.5 liters of solution. We've already got liters, so we really only have to convert our ammonium nitrate into moles. So the next thing we've got to do is we've got to look at our periodic table and look up silver and nitrogen and oxygen. So silver, let's see, right here. So 107.9 to the 10th. We've already got nitrogen. Nitrogen is 14 right here, and oxygen for the nitrate. To the 10th, that will be 16. So 107.9, 14, and 16 is what we need. So silver, 107.9, nitrogen, 14, and oxygen, I've got 3 of them, so 3 times 16. So when I add that up, I get 169.9 grams per mole. Now, I want my grams to cancel, so I'm going to put my grams on the bottom. So 169.9 grams of silver nitrate are in 1 mole of silver nitrate. Okay, so my grams cancel of silver nitrate, and I'm left with moles per liter. So that's really all I have to do. So when I do this, I get, 6.8 divided by 2.5 and divided by 169.9. My calculator spits out 0.0160. Now these 2 zeros at the front are just kind of placeholders. And this would be big capital M because we're doing molarity silver nitrate, okay, for the 3 digits. Now let's see if I can do this for molality. Now molality, once again, molality, we're looking for moles per kilogram, okay? So I have 6.8 grams of silver nitrate, and I have 2.50 kilograms of water. Notice my kilograms of water are already done, so I really only have to convert my silver nitrate. We already did our silver nitrate molar mass, so I'm just going to grab it from the problem before. 169.9 grams of silver nitrate will give me 1 mole of silver nitrate. So with our 3 digits there, we're still going to come up with the same answer. We have 0.0160 molal, little m, silver nitrate. Okay. All right. Number 5. Let's look at how we do this. How many moles of calcium chloride are required to prepare 2 liters of a 0.7 molar? So molar, we are going to, let's switch colors here. Molar, we are still doing moles per liter, okay? But this time, we're not going to try and set up moles per liter. We're going to use that moles per liter as a way to cancel out some units. We're going to start with, let's see, we need moles, so we don't even need molar mass. We're going to start with our 2 liters. We have 2 liters of solution that we want to make, right? And I'm going to use this concentration of 0.7 moles of calcium chloride in 1 liter of solution to cancel out that liter right here. So because I want to cancel out the liters, I'm going to put liters on the bottom. So 1 liter of that solution will have 0.7 moles of calcium chloride in it. Okay, so my liters cancel out, and I'm left with moles, which is what I want of calcium chloride. So 2 times 0.7 will give me 1.40 moles of calcium chloride that I would need to make that solution. Okay, so let's continue on with that same idea. What if I wanted to actually get it into grams? Could I get those moles of calcium chloride into grams? Could I do it all in one big problem altogether? So I'm going to start once again with my 2 liters of solution. I'm going to use that concentration to cancel out my units of liters. So 0.7 moles of calcium chloride will give me 1 liter of solution. Now the last step then is to convert the moles of calcium chloride into grams. So I want my moles to cancel out. So I'm going to put mole on the bottom, 1 mole of calcium chloride. And now I need to figure out my molar mass of calcium chloride. So let's look it up. So calcium and chlorine on our periodic table. So chlorine, we've already done 35.5 right here for the chlorine. Calcium, 40.1 to the 10th. So 40.1, and I've got 2 chlorines, so I'm going to need to multiply it by 2, so 35.5. So when I add up my mass of calcium chloride, I have 111.1 grams of calcium chloride per mole. Okay, so I already have the mole per mole here. I just need to put the mass. 111 grams of calcium chloride. So I'm going to take 2 times 0.7 times 111.1. I have 3 digits, so this will give me 150. Let's see, I really want to see where this rounds. 2 times 0.7 times 111.1. My calculator gives me 155.54. So 3 digits, 1, 2, 3. That last digit tells me to round up. So 156 grams of calcium chloride is what I would need to make that solution. Okay, now let's look at number 7. How many grams of potassium nitrate are required to prepare 800 milliliters of a 1.4 molar, that big capital M is moles per liter, solution of potassium nitrate? Okay, so we are definitely going to need our molar mass of potassium nitrate. So we might as well do that right now. So potassium, let's look that up. Potassium, 39.1. Nitrogen is 14. And oxygen is 16. So potassium, we've got one of them, 39.1. Nitrogen, 14.0. And oxygen, 16 times 3. So when I add that potassium nitrate up for molar mass, I get 101.1 grams of potassium nitrate per mole. Okay, there's our molar mass. So let's start. So I want to make 800 milliliters. I'm going to start with my volume, and I'm going to use this concentration to get out of volume and into grams. Okay, so 800 milliliters. The problem is I have my volume over here in liters, so I need to convert my milliliters to liters. So I have 1,000 milliliters in 1 liter. So my milliliters cancel out. Now I can use this concentration of 1.4 moles, right? I have 1.4 moles per liter here. So I'm going to want to cancel out my liters. So I'm going to put liters on the bottom. So in 1 liter of solution, I have 1.4 moles of potassium nitrate. So there go my liters. They're gone. Now I can use this over here to convert from moles 2 grams. So I want moles to cancel out, so I'm going to put that on the bottom. So in 1 mole of potassium nitrate, I have 101.1 grams of potassium nitrate. Okay, so when I do all of that math, I've got 3 digits here, so I'm going to report 3 digits here. So I've got 113 grams of potassium nitrate. So mathematically, 800 divided by 1,000 multiplied by 1.4 multiplied by 101.1. Okay, so let's look at this. How many grams of potassium nitrate will be required to mix with 800 grams of water to make a solution? So a 1.4 molal solution. So we're going to use now moles per kilogram. And this gives us the same, we have 1.40 moles per 1 kilogram of water. So this is moles of potassium nitrate and kilogram of water. Okay, so once again, I'm going to start with my grams, my 800 grams of water. I don't want grams. I don't want grams of water. I want kilograms. So I have 1,000 kilograms of water in I have 1,000 grams. Oh my gosh, I have 1,000 grams of water in 1 kilogram of water. Sorry, I misspoke. So my grams of water cancel out. I now have kilograms of water. I'm going to use this relationship to cancel out my kilograms. So I want my kilograms to be on the bottom. So in 1 kilogram of this solution of water, I have 1.40 moles of potassium nitrate. Okay, so my kilograms of water cancel out. I have moles, and I want to get to grams. So I'm going to use my molar mass that I did over here. So in 1 mole of potassium nitrate, I have 101.1 grams of potassium nitrate. So my moles of potassium nitrate cancel, and I'm left with grams. Now, mathematically, this is exactly the same as on top, so I'm going to need 113 grams of potassium nitrate. But notice my units are different. Instead of having liters on the bottom, I have kilograms. Okay? So let's go on to number 9. Calculate the volume of a 1.5 molar, so molar is moles per liter. So this will give me 1.25 moles of cyanic acid in 1 liter of solution. So made from 31 grams of cyanic acid. So the first thing I've got to do is I've got to take my grams of cyanic acid and I've got to find the molar mass. So let's look. Hydrogen and carbon and nitrogen. So hydrogen we've already done. It's 1.0. Carbon 12.0. And nitrogen 14.0. So let's add that up. So hydrogen 1.0, carbon 12.0, and nitrogen 14.0. So that gives us a molar mass of 27 grams of cyanic acid to 1 mole of cyanic acid. Okay, so let's start with our grams. We've got 31 grams of cyanic acid, and I want to get that to moles, right? Moles is what I'm after. So I'm going to use my molar mass here. I want my grams to cancel. So I'm going to put my grams on the bottom. 27.0 grams of cyanic acid will give me 1 mole of cyanic acid. Okay, so my grams cancel out. Now I want my moles to cancel out, so I'm going to use this concentration ratio to cancel out my moles. Now to cancel out my moles, that means my moles are going to have to go on the bottom because right now they're on the top, right? They're right here on the top. So I'm going to put 1.25 moles of cyanic acid in 1 liter of solution. So my moles of cyanic acid cancel out, and I'm left with liters, which is what I want. Okay, so we're going to take 31 divided by 27 and divide by 1.25. We've got 3 digits here. So when we do that, that will give us 0.919 liters of a 1.25 molar cyanic acid solution. Okay. Yep. All right. So let's go on to number 10. Calculate the volume of a 3.5 molar. So molar is moles per liter. So that means I have 3.5 moles of sulfuric acid per liter. Okay. And 49 grams of sulfuric acid. So I need to find my molar mass of sulfuric acid. So let's see. Hydrogen, we've already done is, let's see. I don't want. For some reason, I am in the header and I don't want to be there. Let's close that up. Okay, so sulfuric acid, I've got 2 hydrogens, and we've already said that hydrogen is 1.0. We have not looked up sulfur yet today. So sulfur to the 10th is 32.1. Okay, so 32.1. And oxygen, we've already said is 16, and we've got 4 of them, 4 times 16. So when we add all of that up, we have a molar mass of 98.1 grams per mole that we're going to be able to use. Okay, we've got our background, so now we're going to start with our 49 grams of sulfuric acid. So 49 grams of sulfuric acid. We want to get out of grams and we want to get into moles. So we're going to use our molar mass. So grams need to cancel, so the grams need to go on the bottom. So 98.1 grams of sulfuric acid will give me 1 mole of sulfuric acid. So my grams of sulfuric acid are gone. Now I want to cancel out moles of sulfuric acid. I'm going to use that by using this ratio that we created. Moles need to cancel, so moles are going to have to go on the bottom of the next step. So I have 3.50 moles of sulfuric acid in 1 liter of solution. So my moles of sulfuric acid cancel out, and I'm left with volume, which is liters. Okay, I've got 3 digits here, right here. So when I take 49 and I divide it by 98 and then divide it again by 3.5, to the nearest 3 digits, I have 0.143 liters of solution. Okay. All right, let's look at number 11. Calculate the mass of water needed to make a 3.5 molal solution. So molal is going to be moles per kilogram. So I've got 3.5 moles of sulfuric acid per kilogram of water. Okay. Once again, I'm going to start though with the grams. Okay. 49.0 grams of sulfuric acid. I need to get that into moles, so I'm going to use the molar mass that we calculated before. So I'm going to put the grams on the bottom to cancel the grams out. 98.1 grams of sulfuric acid will give me 1 mole of sulfuric acid. Okay, my grams are gone. I have moles. I'm going to use this relationship here to cancel out my moles. Okay, so I need the moles to cancel, so I'm going to put moles of this relationship on the bottom. So 3.50 moles of sulfuric acid in 1 kilogram of water. So my moles cancel, and I'm left with a mass, kilogram of water. Now notice the setup is pretty much the same thing, so the math is going to be the same. So I will have 0.143 kilograms of water in that solution. Not a whole lot. Okay, so that is how you use units for molarity, which is moles per liter, big capital M, molarity, and molality, which is a little m, which is moles per kilogram. Okay? Hope you have a great day, and we'll see you later. Bye.